Today, we're going to demystify Java, which is, one of the most popular programming languages on the planet. We're going to break it all down piece by piece and treat it just like an architect's blueprint for building some really incredible software.
So, here's our plan. We'll start with the big philosophy behind Java, then look at its basic building blocks, see how we actually make the code think, check out some smart design tricks, and finally, wrap up with the safety features that hold it all together.
I mean, we use this stuff every single day, right? But have you ever stopped to think about what's actually going on under the hood? It can feel a little bit like magic, but really, it's all built on a very clever and super organized way of thinking.
And that secret? It's a concept called object-oriented programming, or just OOP for short. Now, this isn't just some Java thing. It's a huge idea that totally changed how we build software. It made our code way more organized, way more powerful, and honestly, a lot more like the real world.
Okay, so let's dig into that foundational philosophy first. I want you to think of this as the architect's grand vision, before a single brick is even laid. This is the big idea that really shapes everything that comes after.
So here's the key. Instead of just writing a long, boring list of instructions, OOP lets us create these little self-contained things called objects. Think about a car. A car has data, right? Its color, its current speed. And it has actions it can perform, like start engine or accelerate. Well, OOP bundles all of that, the data and the actions, together into one tidy little package.
All right, so with that philosophy in mind, let's look at the actual raw materials we get to use when we're building these objects in Java.
The most fundamental piece of the puzzle is the class. Now, if we're building a house, the class is the architect's super detailed blueprint. It doesn't build anything by itself, but it defines everything. How many rooms? What kind of roof? Where the doors go? It is the master plan.
And, well, if the class is the blueprint, then the object is the actual physical house that you build from it. What's cool is you can use one blueprint, one class, to build tons of houses or tons of objects. Each house is its own unique thing, but they all follow that same core design laid out in the class.
So how do we define the specific details of our house, like its paint color or the number of windows? That's where variables come in. They're just containers for data. And in Java, you have to tell it what kind of data you're storing. A number is an int, some text is a string, and a simple true or false value is a Boolean. These are the basic materials specified right there in our blueprint.
Okay, we've got our blueprints and our materials, but a house that just sits there isn't all that useful, is it? We need some instructions to make it come alive. So let's see how we make our code actually think and act.
We give our objects actions using methods. You can kind of think of these as the verbs. So our house object might have methods like open door, or turn on lights, or maybe set alarm. These are the specific jobs the object knows how to do, and they're all defined back in that class blueprint. But how does a program decide when to do something? That's where control flow comes in. It's really simple, but it's incredibly powerful. For example, if the doorbell rings, then open the door. Else, if nobody is there, then just keep the door closed. This basic if-then-else logic is the bedrock of how programs make decisions and respond to all kinds of situations.
All right, now we're getting into the really clever stuff. These are the advanced building techniques that make Java so efficient and so powerful. They let us build massive, complex systems without having to start from scratch every single time.
So check out inheritance. Imagine you have a perfect blueprint for a building. Now, if you want to design a skyscraper, you don't start over, right? Of course not. You just take that building blueprint and add to it. Make it taller, add an elevator. That's inheritance. A new class, the subclass, gets all the features of an existing class, the superclass, and then just adds its own new stuff. This idea of reusing your work is a total game changer. It's how developers manage these huge projects without rewriting the same code a million times.
And this slide shows it perfectly. We start with the general vehicle superclass. It's got wheels, it's got an engine. Then, when we make our car subclass, it automatically inherits all that stuff. We don't have to redefine wheels or engine for the car. All we have to do is add the new things, like a trunk. See how efficient that is? It's awesome.
Now, building right on top of that is something called polymorphism, which literally just means many forms. Because a car is a vehicle and a motorcycle is a vehicle, we can treat them both as just generic vehicles whenever we need to. This lets us write way more flexible code that can handle all kinds of different but related objects without a hassle.
Then you've got abstraction, and honestly, this is all about keeping things simple. When you drive a car, you use a steering wheel and some pedals. You don't need to understand the complex mechanics of the engine or the transmission to do it. Abstraction is that exact same idea in code. It hides all the messy, complicated details on the inside and just gives you a simple interface to work with.
Okay, so we've designed a smart, functional building. Now we have to make sure it's safe and robust. Let's talk about the safety codes that are baked right into Java's design.
We'll start with encapsulation. Remember how objects bundle up their data and their methods together? Well, encapsulation takes that a step further by basically building a protective wall around them. This keeps an object's important internal data safe from being accidentally messed with by other parts of the program. It's like putting everything in a secure little capsule. But look, no matter how well you build something, unexpected things are going to happen. A file you need might be missing, a network connection can just drop. So what happens when things go wrong while the program is actually running? Well, Java has a plan for that too.
It's called exception handling, and it's basically a safety net for your code. You tell the program to try a piece of code that you know might fail. If an error or an exception happens, the program will catch it and handle it gracefully instead of just crashing and burning. And that finally block, it runs no matter what, which is perfect for any cleanup tasks. It's a really solid system for dealing with the unexpected.
So that's really the whole blueprint. We've seen how Java uses object-oriented programming to model the real world, right? We've got classes as the plans and objects as the final product. We've also touched on smart techniques like inheritance to build things efficiently, and those built-in safety nets like exception handling to make sure our code is tough and reliable.
And you know, like with any blueprint, the real understanding, the real fun, comes from actually building something. The absolute best way to get a handle on these concepts is to just dive in, start creating, build small projects, experiment, and you'll see how all these ideas come to life in your own code.
So, we've laid out the entire plan, from the core philosophy all the way to the advanced safety features. The blueprint is now in your hands. The only question left